let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Hey, good afternoon. I'm going to call you all GitOpsians now. That's what we're going with. Good afternoon, GitOpsians. We are at episode 42 of GitOps Guide to the Galaxy. This is the quintessential episode because it is number 42. So for those who might not be old enough or be aware of Douglas Adams' Hitchhiker's Guide to the Galaxy, you can see where we kind of got the name from. The number 42 is the answer to life, the universe, and everything. We still do not know the question, but nevertheless, today is the absolute best episode. A couple announcements before I introduce our very exciting guest. So actually, it's just one. You will be able to see me talking about Helm and Kubernetes operators at DevCon US in Boston, DevConf US in Boston. On August, I think I'm speaking on the 17th. But anyway, find me there. If you're going to be there in person, say hi. That is a really great conference. Lots of people will be there. Other people from my team and organization will be there as well. So it's a great opportunity to kind of get in and hear about stuff that Red Hat and other companies are doing and what's happening. So moving on, I'm going to introduce our guest, Nitin. He is CEO of a company called Robusta. Robusta.dev. And before I have him talk more about what Robusta is and does, which is things that I'm very excited about because it's in GitOps and observability and it's open source, let me tell you how he and I met. And this is great because he and I met by arguing on LinkedIn about CPU limits in Kubernetes. And in support of Nitin and how excited we are to have him here, I'm wearing the shirt that he gave me at KubeCon Valencia. While he and I were not necessarily in agreement on this situation, I really appreciated the T-shirt. And so that's it. Nitin, introduce yourself. Talk to us about Robusta. I think you said you have some demos for us. Let's just let you get started.
So thank you very much for having me. And it's especially exciting, like you said, to be here on episode number 42. I've also always been a fan, though I didn't bring my own towel. Nice reference there in the chat. And for us, the question, I guess, is what do you do when stuff goes wrong in your Kubernetes cluster? And how do you debug stuff in 2022? So if we look at it, then many of us are all running Kubernetes clusters. Many of us have live alerts in our Slack channels. And many of those alerts are really the same alerts. And at the heart of that really is the need out of which Robusta was born. And my co-founder and I, we were both developers. We worked at a company. We did Kubernetes security. So we developed for Kubernetes. And we kept seeing that we had all these alerts piling up. And we would speak to our friends, and they also had live alerts, often alerts with the exact same name, the exact same issue. And each of us would then go and we would start to investigate those alerts and look into them and try and understand what they meant. And we really like the GitOps philosophy, where you're essentially taking the knowledge for how to set up your infrastructure and you're putting that in a file in your GitHub repo. So you're using infrastructure as code. You're saying, here's a file, and that file is all the knowledge in the world for how to set up my infrastructure. And we started thinking, could we do the same thing for how we respond to alerts, for how we investigate alerts? Can we take the knowledge and take it out of my head where I know how to investigate a certain alert, or I know what that alert means, or I go and I read a blog online about how to investigate it, and can we put that knowledge really into GitOps file in our repository and turn that knowledge into code? So out of that, Robusta was born.
I mean, that is a story, an origin story that I definitely personally identify with. The cool thing to me, right? The thing that I thought was the coolest was that you not only have you've created a platform. I think you mentioned you've got at least 100 users that you know about, but the other half of that is, right, you have this that you've open sourced a part of your solution as well. And of course, me being somebody at Red Hat being Red Hat, like we're so excited to see that it's 2022 and people are still, let's have a company and we're going to open source stuff because we're so proud. I think we're so proud of what we're doing, and you should be too. So I'd love to hear if we have some time about your open source journey, but I also want to make sure you've got plenty of time to show us all of the cool things you wanted to show us today.
Okay, so I'll start with just a word about running an open source company or an open source based company. And the time has never been better for that, because there's really a number of large companies now, or very successful companies, like HashiCorp, like Elastic, like Redis, that have proven that model can work. And Red Hat has a little bit of an outlier in terms of the business model and in starting off more of a support-based strategy. So there are a lot of other companies, though, that have really shown to VCs and shown to the world that it's something that you can do, and you can do it successfully, and even build a huge company around that. So there's never been a better time to start a company that has a heavy open source part. Now, speaking about what we do, then really the core of what we do is three things. The first thing is we have an engine that listens to all the events that happen in your Kubernetes cloud, and you define in YAML triggers and actions. So you can define, for example, when this trigger happens, then this is the action I'm going to take to investigate that or to fix it. And I'll show you some really specific examples in just a moment. The second part of it is, an engine is no good if you don't have any rules. So we don't want to just give you an engine and then say, okay, now go put together your own recipes, put together your own rules, do all of that. What we want to give you is we want to give you the whole experience. So we want to give you an out-of-the-box solution that knows how to take the common issues in your Kubernetes cluster, and then it knows how to tell you for each of those issues what to do and how to fix it. So that's the second part. And then the third part, which is the only part that's not open source, is we have an optional add-on UI that runs in the web. And that SaaS platform gives you a single pane of glass where you can see all your clusters, you can see what's going on with them, and you can troubleshoot issues from there. By enough talking, I think I should just show you guys the code. So let's dive right into an example. And I think it'll all make a lot of sense then.
Take us on a tour.
From the chat. Pleasure to see you. So I want to start with a really simple example. Here's an example that we've all seen. We have crashing. When the pod crashes, I guess the question is, what's the first thing that you're going to do if you decide that you want to go and investigate that? I guess I know me personally, what I would always do is I would go and I would then go and run kubectl logs, and I would fetch those logs and look at the logs to see if there's anything there. So here's an automation that automates that exact process. So what we're doing here is we're defining the trigger. The trigger here is a Prometheus alert. There's no need to invent the wheel. You already have Prometheus alerts firing. So let's take your existing Prometheus alerts, and now let's hook them up to Robusta. So when a Prometheus alert fires, and that's the alert for a crashing pod, that's the trigger. And the action is just to fetch the logs. Now, what's going on here is when this fires, we're Kubernetes native. So this is the trigger, and that trigger has data about the pod. It's a Prometheus alert that's firing, that's related to a pod, and you can map that according to the labels on that Prometheus alert. That goes from Prometheus to Alert Manager to Robusta. And when Robusta gets it, it has a pod object and knows which pod is crashing. And therefore, you can just define here an action that says, okay, let's fetch the logs from that pod. So we've taken an alert, and we've now attached this extra debugging information, which is the logs. And then the last part is just where do we send that data? So we'll send it to Slack. And let me show you what that looks like. So if I jump over here to my Slack, then here's just an example that just arrived from my demo cluster. So you can see here, here's the alert. And you can see right here, I'm just pulling in the logs. We have here the world's longest Java exception. So it's a bit of a contrived example. And we're pulling in that data so you can see here exactly why this pod is crashing. Now, this specific issue though is just one example of one rule. So I've actually got automation here that will also pull in some extra data. So you can see we're actually pulling in the pod events as well. So that's like running kubectl get events. and then filtering out that to the events that are relevant to that pod, and then we attach that extra data here. So the concept is you can take any other or any issue that's occurring in your environment, and then you can gather automatically all the debugging data that you need, and you just define that in the YAML file. So that's been a lot. So let me stop for a moment. And Hilliary, I don't know if this is the first time maybe I've walked you through a full example.
Yeah, it actually is the first time you've walked me through a full example. I will say, like, you know, what you said, we basically automated and put into ChatOps a very normal workflow, right? The workflow you've described, I have done exactly by hand. I think the only difference is every time I do it, it's OC instead of kubectl or kubectl, depending on your flavor for saying that. And so I'm gonna lie, I had a moment where my brain froze when you said kubectl, and I was like, "What's that? Oh, right."
Yeah.
I have had stories of being tired and mucking about on my own, like kind clusters or whatever, and wondering why my commands were not working, only to realize like 15 minutes later that that I was using OC instead of the Cube API directly, and that was why my stuff didn't work. So for those of us who have OpenShift on the brain, yeah, you know, mental replacement,
Yep.
and everything is fine. But yeah, this is a workflow my team, I mean, we do it almost every single day, right? So to see it just put into Slack for us, that can save, and we were talking about needing to resolve an incident, right? In the meantime to resolve, that can save as much as 5 to 10 minutes in actual manual work. And so that, I think, you didn't mention it, but for me, when I'm looking at it, that's one of the most important reasons for automation to exist, right? Because we're promising what 3.5 nines SLA on most Red Hat products.
Yep.
That does not give you a lot of time for an incident, right? You have to be fast, and I love anything that makes us fast.
Yep. So then moving on, like taking that and expanding on it, then the obvious next question is, okay, well, can we also do ChatOps, and can we fix stuff, right? And here there actually is an inherent conflict with GitOps, because when you fix stuff, then you don't want to fix it live in your cluster. Really, the way that you want to fix it is you want to go and open like a PR to your GitHub repo and then change it there. So if you're going to go and fix stuff in cluster, then it really here we're starting to break a little bit the GitOps model. So we see here two philosophies. Philosophy number one is everything should go through GitOps no matter what. And really, like philosophically, I think that's the correct way. And that's the direction that we're going to be moving in with these type of remediations that we implement. We don't have that yet today. But in the interim, what we do have is we do let you make these temporary fixes in your cluster directly from Slack. So you can click a button in Slack, and automatically that will go and it'll make a fix on your cluster. And that's very good for workarounds. Let's say you want to restart a pod, or let's say you want to drain a node or do something for a specific alert, but isn't really a GitOps type of change anyway. It's more a status change than a spec change. Then you can do these different remediations from Slack. So I'll show an example maybe on that. I'm just going to bring it actually up from the docs. I don't know if I have it set up here. So if I go to the docs, here's just one example like that you see. So here, the HBA reached the maximum number of replicas. So you got a quick workaround that you can do. You just push that button replicas by 30%. And then you are going to want to go and commit that to Git, or in the morning, you're going to want to go investigate that and do that properly. But you get that immediate quick mandate that sometimes lets you maintain those SLAs.
Yeah, and that's really the balance we have to strike, right? And you know, Red Hat, we have GitOps for certain types of incidents, specifically around anything about capacity to do exactly this type of thing. But you know, we had to create the GitOps tooling and integrations to do that, because before that we were having to do it by hand and then retroactively like go back and you know, it's the equivalent of like remembering to go back and update the documentation after you've made the change, right? You know, you got to do what's needed to maintain SLA, but it is double work. So every time Git can be the source of truth, that's the best, hands down.
Yeah.
Also, typically, if Git's your source of truth, you're going to have actually some level of testing likely baked into your Git, so you're not realistically doing things in production completely untested. And
Yeah,
I
that's
think
true.
11 years in quality engineering, let me tell you how important it is to test things before you do it in production.
Oh yeah. We've all been there, and there are two types of people in the world. There are people who know that, and there are people who don't know it yet.
Yes, I think that's a really good way to put it. So yeah, and I really agree with you on when you went and you said like there's kind of like that dichotomy of you have to fix the issue. So like ChatOps allows you to just like quickly slap the band-aid on, and the other part is you have to have record of what you did to fix the issue, and so that's why Git needs to be the sort of truth. And yeah, I think whenever we can use Git and GitOps to do incident response, we're better for it. And if there's a problem in our incident response via GitOps, then we can life cycle and maintain that, and we can bake that into the testing cycle of the product even. So you can always basically guarantee your operations by doing operations as code, which is actually one of the big cultural changes that we've been working on implementing in Red Hat is getting all of our ops pieces actually into the QE cycles. And we've had some pretty excellent partnerships from our QE teams to do this because Red Hat has an initiative called Operate First. Our QE teams have been pretty heavily involved in that, in addition to some of our developers and some of our operational groups, to kind of create this concept that you need to know your day two operations. And a lot of times day two operations is actually incident response. So you need to know them, have them codified, have them tested. And anything that makes that better or makes that happen faster for groups is a tool that I can get behind.
Yeah. So that's a big part of it. I mean, big part of it is really taking that knowledge that you have. Like I've seen it happen where I'm eating dinner with someone, and in the middle of eating dinner, like a friend of mine gets called on the phone and he has to explain exactly what commands you should run, and say, okay, go run this command, and like almost reading out letter by letter what commands someone should go and run who's dealing with an incident right now. Like you should really be able to take that knowledge and codify that just as a GitOps response. And I mean, that's what we're really trying to do. By letting you go and by letting you define these YAML files and by letting you say, okay, like here's the trigger, like this is the alert that's firing, or this is the whatever incident happened. And then here's how you should go and fix it. And here's the workflow to do that, either automatically or semi-automatically.
I also love that it's done with YAML, right? Because at this point, YAML is becoming like almost like it's just like a language we all know. Not even language, but you know what I mean, right? It's like a language we speak, right? We can, a lot of us can lint YAML in our sleep, basically. So for that kind of normalization, that's the word I wanted. That kind of normalization across all of my tools and everything I have to look at. Like this is also in YAML, right? That for me, that is huge. It's one of the things that's why I love Ansible so much, right?
Yep.
People will be like, oh, automation, blah, blah, blah. I'm like, okay, but Ansible. And like, yeah, okay, maybe I'm slightly biased because Ansible's in part of my division at Red Hat, but I loved Ansible before I got here. So
Ansible is an interesting one because, right, Ansible is configured in YAML, but then you extend it in Python, right?
Yep.
So now's a good time for me to speak about like what exactly are these actions, right? Because it's actually the exact same model. Okay, so if I want to break this down again, then like every automation that you're going to define in Robusta has a trigger, has an action, and it has the sync. The trigger is what's triggering this automation to kick off in your Kubernetes cluster. The action is what data you're gathering or what automatic or semi-automatic remediations you're suggesting to the user. So what buttons are you giving them in Slack? And whenever I say Slack, like if you work at a company with over 1,000 people or over 10,000 people, just replace that in your head with MS Teams. So it's Slack or whatever other messaging app that you're using. And then the syncs is the destination that you're sending that to. So if we look at this now, I'm going to break that down a little more and show you what each of these parts really is. So if I jump over to our documentation, then I can just go down here, and here we have a section on triggers. And if I click here on the triggers, then I can see all the different triggers that you can put into Robusta. So from Prometheus and Alert Manager, that's what we were looking at so far. Changes from the API server. So for example, if a deployment was updated, maybe you want to send a notice in the Slack channel 10 minutes after deployment was updated and say, okay, like here are the graphs how that application is performing after the latest update. And then various different triggers there. So cluster, and under the hood, that's powered by what was once KubeWatch. Bitnami developed KubeWatch, then Bitnami got acquired by VMware, then the project was abandoned. Now, if you go KubeWatch on GitHub, it refers to us. We took over the official fork for that. So that's what's powering this under the hood. And so you have various triggers. You have here the triggers like Prometheus, like Kubernetes. You can do triggers on the schedule. You can do triggers that you trigger manually by running the command line or by webhook. You can take triggers from Elasticsearch. So all these different integrations. And that just is the first part over here, the trigger for what's going to kick off this automation. And again, I want to emphasize what it means here to be Kubernetes native is that each one of these triggers has a Kubernetes object that's attached to it. So if a trigger was a deployment that updated, then there's a deployment object attached to that that's flowing through this pipeline, and the action will get as input a Kubernetes deployment. If here you have a Prometheus alert that's firing on a pod, and it's mapped to that pod by the alerts labels, and that pod exists, then what's flowing through this pipeline is a Kubernetes object. So these actions are typed. So now I'm going to jump over to these actions. So you have a trigger, fired off a trigger with a Kubernetes object that's associated with it. And then if we go over here, then there are all these different built-in actions. So there are actions that will grab a graph from Grafana and render it. There are actions that will take an action or allow you to take an action when you click a button. There are actions that will pull in the Kubernetes events. There are actions that will run a CPU profiler on the Java application. There are actions that will grab a stack trace from a Python program that's running inside that pod. So there are all these different debugging actions that can gather this wide range of data. But I want to show you what those actions really are. So if I take, again, this logs enricher action, I'm just going to jump over to the source code for it. It's just a Python function. And I want to show that.
Can you, yeah, beat me to it.
Is that better?
Yes.
Yeah, I've done enough demos by now. Okay, so you see here this action. That's the action that we configured in YAML, and it takes two inputs. So the first input here is the pod event. And that event just lets me get the pod itself and fetch any other metadata. Now I have here the pod object, and I can just do anything I want now in this Kubernetes pod. So I can access all the YAML fields. I can read them. If I wanted, I could write them. I can access here the containers. I can grab whatever data I want from over here. And I can also do actions, call different APIs like pod.getDocs. Whoops. I'll do here pod.getDocs. And if I save that to a variable, there's some latency in the chat, so I'm typing things. It shows up later on me. So if I fetch those logs, then I have here, and I can very easily attach that to the outgoing event, so it just gets sent then to Slack, or MS Teams, or wherever other destination you're sending this to. So it's very easy to write action like this, but then have logic that's even specific to your application, with logic that's specific to a specific type of error that occurs. So let's say, for example, you have an error that's firing on a bunch of 500 errors in your application that's serving HTTP traffic. And you say, okay, now I want to go and I want to grab, like from Istio, the network tap with data on what's going on, and I want to attach that now to this alert that I arrive in Slack. So we haven't written an action for that yet. I mean, we probably should at some point. But if you wanted to go and write an action like that yourself, it really would just be a few lines of Python. And then it's very easy. We have an API that wraps the Slack API in MS Teams. So you just say, attach it to the outgoing message. Now, I see we also have a question from the chat, right?
Yeah.
Do we want to bring that up on screen? I think the question is that you could take a live system in knowledge or responses and consider machine learning applications. And the answer to that is absolutely yes. And we're approaching this here kind of in the opposite direction. I think there are some companies that say, okay, we're going to gather all this data, and then we're going to throw a machine learning algorithm at it. Yep. It's a very cool approach. We're approaching that from actually the opposite direction. We're saying, okay, we're going to gather all this data. We're going to hand write the first 100, 200 responses. And we're going to really, for each one, we're taking an alert. We go on Stack Overflow, we research it, we read through the Kubernetes documentation, we look through the Kubernetes source code, and we try and figure out for each common error and for each alert that people tell us about that's going on in their cluster, try and figure out what's the correct Robusta way to solve this. And really, what's the best practice for this? what would the world's best sysadmin do who's familiar with Nginx when this Nginx error occurred? And then we take that knowledge and then we turn that into an automated playbook and we push that out in the next version to all the users of Robusta, assuming they've opted in to get those updates. So we're not doing it today with machine learning, but I think the real valuable part of this is you're building out this very valuable data set, and you're building out the sample size, and you're also building out kind of this training set for what responses then like people use or don't use, assuming that they opt into sending data to you. We actually don't gather that data today. We gather very, very little, and you can disable telemetry altogether. But if people want to opt into that, or if they want to run some machine learning model, maybe on stuff specifically in their own environment, where they want to see for all the different responses, what's most effective or what reduces them TTR the most, then you have all this architecture and these models, and you can put it on top of that. And I think the advantage of starting off with more of a signature-based approach is that you really get to do stuff that's really, really fine-tuned. Like if I get back to our discussion on CPU limits, what kicked this all off was we actually wrote a Robusta remediation that said, okay, you have CPU throttling. What should the proper fix for that be? How are you going to fix CPU throttling in your cluster? And the sort of answer there is really, really nuanced. And like even you and I even won't agree about the answer to that. But
I think we agree on the answer depending a little bit on the environment, right? Because we talked about, if you're not using the CPU cycles, you're wasting your money. But I've also done Kubernetes on bare metal. And just because you can use all the CPU cycles doesn't mean you want to, because the more you use your CPU, the harder your hardware runs, the more you impact your hardware life cycle, right? These types of things that you have to keep in mind, depending on literally all the way down to like your hardware situation. So I think I do want to say, I do agree there's lots of opportunities for limits to not become necessary. And then there's times where I think that CPU limits can be very important. And of course, you don't want to overclock your physical CPU if you don't have to. Now, if you want to overclock somebody else's CPU because they're paying for it, the hacker in me supports this.
Okay, so that's a really cool example. Because you know what I love about that, though? It shows something that we deal with all the time, which is that the answer to specific alert is it depends. Very, very often. So, for example, I'll give you like a really specific instance where when there's CPU throttling, you want to ignore it. If you're running on GCP and the CPU throttling occurs on metric server, then you want to ignore that CPU throttling because there's no way in the world that you can fix it. Like metric server is managed by GCP, by the Google Kubernetes engine. And if you change like the CPU limits, you change anything, it just rolls back the change. But I can tell you that anyone who installs Prometheus via that Helm chart on the Kubernetes, by default, every single person who uses default alerts has that alert firing and taking up room in their Slack channel. And ultimately, you get this alert fatigue, and you stop looking at the alerts because there's this stuff in your Slack channel that's just pure garbage. Yep. And I can tell you, though, anyone who takes the #1 Helm chart for installing Prometheus on Kubernetes, anyone who takes that will have this garbage alert firing all the time, and there's nothing you can do in the world to fix it. So now if you add in a tool, then like Robusta, what we actually do is we actually take that specific alert, and we have code in there that checks, are you running on GCP? Is this alert firing on metric server? And if it is, then we just silence the alert. We don't bother sending it to you because there's nothing you can do about that in the entire world. So here's an example of how, like, here's an automation, and this one automation has suddenly saved hundreds of people, thousands of Slack messages that otherwise would have just taken up their time and attention when there's nothing they can do about it.
Yeah, I call that mental toil, right? It's the mental toil of having to remember that something's unimportant, and then your brain will start to filter the white noise. So you have to try to like override your brain's white noise filter, be like, no, I still have to check these Slack channels though. This is something that we battle every single day, that exact like almost mental exhaustion from being overwhelmed by alerts that don't matter, you can't fix. I do want to go back to the machine learning concept a little bit though, because this is interesting. And I've actually recently looked at some tools that do apply machine learning. And I really feel like there's a crawl, walk, run approach here. And I think that if you want to apply machine learning, you need to deeply understand your environment and what your data truly means before you can actually start really training a machine learning model. So what you were talking about earlier, Natan, about how like all that manual fine tuning, I think that's really important. When we start looking at, almost every workload Red Hat SREs deal with is a Kubernetes operator based workload. And that is kind of the same thing. We've taken that operational sysadmin knowledge, we've codified it into a Kubernetes operator, which will it reconcile. So the operator has operands. If you already know this, I'm sorry, but this is for those people who might not.
No, go through it. It's excellent. And maybe we can also touch on operators for something like Robusta, which is very interesting.
Yeah.
Keep going.
Yeah, I love talking about that. So an operator, it extends the Kubernetes API, it extends the ability to have a stateful environment, and it actually basically puts that on the application layer through the use of custom CRDs. And so the Kubernetes operator watches its operands. Those are the Kubernetes objects that it needs to keep in touch, and it's expecting a certain state for those operands, right? So if it's expecting a pod to be running and the pod is not running, it'll restart. It'll delete the pod or restart it, right? Or it might say, okay, I'm expecting 3 replica sets and I have 2, so I'm going to increase it back to 3. This is codified human knowledge, but they are very robust pieces of software themselves, and they do fail as well. In fact, the talk that I'm going to be giving at DevConf is one I've given before a couple times, called Helm and Back Again. And I actually talk about some of the failures and problems with the Kubernetes operator model, like some of the gotchas, when I do a comparison between those two tools. And so
you have to send me the link to that afterwards. I actually really want to hear that.
I can send you the link to the previous. I did it for DevConf Brno in January, and I need to update it a little bit because there have been new features added to Helm that I want to account for. I want to get deeper into the Ansible operator because you can do a Golang operator or an Ansible operator. And since the operator SDK is Ansible under the hood, I like just using the straight Ansible, like let's just keep it clean. But it'll be mostly the same talk, mostly the same content. So I'll send you that. And so, gosh, I lost my train of thought because the church is saying amen now. What was I saying?
You were talking about the operator and how the operator pattern also codifies.
The operator codifies the human knowledge. So it kind of, I want to say, usurps the need for machine learning on a lot of these to a degree. And then into the operators, right? Operators have a maturity model between 1 and 5. And a level 5 operator is amazing because that operator will auto-scale your application. There's deep insights, additional monitoring and alerting and metrics and everything. And all of this is, of course, kept in Git. So I love it because it's very GitOpsy. And so the operator model sort of usurps the need for machine learning because it creates a codified life-cycled way of applying human knowledge across n number of instances of your application in a way that Helm can do, but doesn't fully extend.
Yeah. So it's the same with the Robusta. I think it's a good opportunity to talk a little bit about the difference between operators and Robusta. And the way that I look at it is if you have a desired spec and you want to bring your status in line with that spec, then you want an operator. And what operators are always doing is they're running this reconciliation loop, right? And you're comparing your spec, you're comparing like the status where you are right now to the spec and where you want to be. And then you're bringing those two in line. And I always think about this in the way the Kubernetes documentation describes it, which is in terms of robotics and control loops. When I was in high school, I participated in a robotics competition. And like the hardest thing we did was to try and get the robot to drive in a straight line. You put on the motors on full speed, you set the left motor equal to the right motor, and it goes all the way to the left because one of the motors is actually in practice stronger because hardware is a pain in the ass. So what you always do is every control algorithm, typically PID when you're in high school, and you're looking at like, where are you proportionate to where you want to be, or looking at the integral, or looking at the derivative and trying to bring yourself back in line and like turn left or right and adjust the speed on each motor. So that's how I view like Kubernetes operators. I don't know if you view it the same way, but that's at least like my mental model that I sort of have.
That is a great mental model. I think yours is better and more accessible than mine is. I've always just been like, man, it's a lot like an old school daemon, right? Just like a Linux daemon. It's just continuously running software that does some things, which is like the most like basic and reduced down explanation for what an operator is possible. So I think yours is better, and I'm going to steal it.
Okay. So what's cool about operators is that it's not event driven, meaning like to some degree, you don't care about the history. And again, maybe this is different for certain types of operators. Like if you look at even the built-in controllers or like a daemon set, right? Like, or a deployment, it doesn't care if 5 minutes ago you had like 10 replicas and now you have 5. Like you're just calculating at any given moment in time. And that makes it really easy also to write robust software because you're always recalculating, you're always adjusting. You don't need to care about all that history. But from an observability perspective, sometimes that's really shit. Like, let's say you have a pod deployment and it's crashing constantly. And every time it crashes, then like your customers have a horrible experience. I know lately I keep going on LinkedIn, getting like a blank page and have to restart it. I get these 500 errors. Like every time you're going and you're browsing somewhere, it's crashing. You're dropping connections, but you keep bringing like the thing back up and you keep looking at the spec and the status. You're ignoring the history. So like, from an operator's perspective, everything is fantastic, right? Like a reliability perspective, it's really, really awful. Like in Kubernetes, you like to say, like think of pods and your workloads as cattle, like not pets. But if all your if your entire flock is dying, or like 50% of them are dying and then coming back to life, and they never get it past age 5, like you have a problem there. So the operator perspective is really, really useful and excellent for building great, robust software. But when you're trying to do observability, you actually want something that's event-driven. So that's the difference. Like I wouldn't try and build any sort of operator with Robusta, because when you're writing something that's like comparing spec and state, you don't want something that's event-driven. But when you're doing observability, actually what's event-driven in the state changes, they really, really matter.
Yes. And I touch on that a little bit actually in the talk that I referenced as well. I should just make you be my co-speaker on this talk. We would have such a good time doing that one together. Next time I submit it, I'm going to just list you without even checking.
I don't feel that I'm worthy, but whenever you want to list me on the code talk, I would gladly do it.
I love talking with a person because it ends up conversational like this, and we can like teach each other things we really maybe didn't even know we didn't know rather. So I don't actually like talking alone. I hate it. But I actually have a couple production stories to exactly illustrate the points that you said. I don't want to cut you off on your amazing demos because I think this is really fascinating. But I also would love to tell you about like some like real-time disasters that I've dealt with that are really in line with what we were talking about.
Yeah, please do. Of course.
Okay. So the first one, right, that it's not event-driven. And that is, I frequently call the reconcile loop in an operator a double-edged sword. Because sometimes you just want things to fail because you need to know they're failing. And the operator will hide failures by reconciling state. So you can have something crashing and, you might not necessarily always catch it. And you can actually tune that in the observability so that you can catch if something's crashing and restarting a lot. And there's a lot of ways to tune that. And in SRE, we actually spend a lot of time working on making sure alerts and warnings are tuned and resolved. So that's cool.
What's the best way to do that, though, to like output Kubernetes events then?
Yeah, it's just actually another implementation of Prometheus and Alert Manager. And there's a few other toolings in there. So that's a double-edged sword, that reconcile loop, right? Because sometimes you want a failure, you want to know that it's failing, right? And it's not necessarily revealing that there's a problem, right? A pod might get up, start running, run for 5 minutes and crash, and it restarts. Well, if it restarts fast enough, some of your alerting is not going to catch that there's an issue, right? And you end up finding out from the customer. That definitely has happened a lot. The other thing is you talked about it doesn't know past numbers. Like that 5 minutes ago, there were 15 pods instead of the 5 it's expecting. This actually just happened to us. There was a problem at startup in a pod for when it was trying to determine how many basically other pods, and I'm trying to like reveal this without revealing like all the stuff. But basically there's this pod that runs a controller. The controller says, okay, based on XYZ factors, I need Z number of pods to do some networking stuff, right? And so it creates Z number. So there was a problem in that math. And instead of creating 2, it was creating 22. And this actually came from the open source upstream. It actually wasn't in like the Red Hat. I'll say it's Red Hat's fault because we're contributors on the upstream, but it wasn't like Red Hat's own. Like we weren't the only people at fault. It's an upstream open source project.
Okay.
lots of big companies contributing to, not just us. And so that math was wrong. And due to pod disruption budgets, when it was spinning up all these random pods, the CPU allocation and the memory allocation wasn't such that it could actually sustain 22 because that was a ridiculous number. And so looking at pod disruption budgets, these had a higher priority than some other pods did. So those other pods got killed for not enough CPU, not enough memory. And the new 22 pods got started. Well, then the operator caught that was too many and reconciled it back down to the correct number. And because the operational knowledge was baked into the operator, whereas the controller that, was installed by the software had a mathematical error. And then when that happened, the other pods that had been killed all came back up. So we were seeing up and down outages in production, right? And we're like, why is this? And of course, there's a cron job at fault here. There's a cron job that's restarting some stuff or checking some stuff and starting up the process to calculate every so often. So there's always a cron job, I swear. And so that it was terrible because the operator kept fixing it. It took 3 SREs all watching different parts of the cluster to see, wait a minute, that went up to 22 and then went back down to 2 within the 5-minute reconcile loop. And that's why we're having all these problems. And then we're like, well, where's the bug? Oh man, that took another several hours to suss out. That was a ridiculous incident. The RCA was amazing.
One of these days, what I really want to do is I want to do a Kubernetes flight recorder where you take a given object and then you just track all the various changes that it undergoes and why. And it's not hard to do. It would be fairly trivial to even write, but just to give you that whole story. We do some stuff in Robusta that touches on it, but it's really aimed at a different use case, not for the use case where you're writing operators.
There's a company called Ops Crews, and they actually do it. And they also have some machine learning applications as well for the earlier comment about machine learning. That's a really cool tool. I recently got a demo from them. That's a super neat tool.
Cool. Yeah, I have to check that out. Mate. So, but you touched on a lot of stuff here that I'm really passionate about, and that we end up speaking about a lot. Because that case where you have a pod that's going up and down, we see that all the time with kills. Someone says, okay, I have an kill. And you look at the graph then, and you see the kill looks like this, the graph of the memory usage. Maybe I can even show, let me see if I can show a specific example. It's probably best if I just open it on LinkedIn instead of searching through my Slack.
Oh yeah, I'm trying to think if I have any handy. I don't think I do.
Let me see if I can open that very quickly.
Well, while you do that, let me just look back through the comments. We got kind of very passionately monologuing, and I want to make sure that we didn't miss anything from anybody. Hindsight is bliss. Yeah, hindsight is bliss. I agree with that. So I'll take advantage of this little bit lull because I think we're going to go right up to the end today because of how just amazing this content and conversation is. To remind everybody to like and subscribe to the channel, please. So that they will let me keep doing this. That's very important. And then if you don't already follow me on Twitter, follow me on Twitter. I'll post the Helm and Back Again talk, the YouTube video for it. And Nathan, I will go ahead and, or Natan, excuse me. I keep doing that. Shame on me. I'll go ahead and tag you in it too. So if anybody who follows you might also see it. But also follow him because he posts good content very regularly. You recently just posted a great, what are the best Kubernetes for Dummies videos. I loved that thread. That was an amazing thread. Yeah,
thank you. Thank you very much. Okay, so I need to see if I can actually find a good example here with Umkel. I didn't find it on LinkedIn either. I should.
I know, right? I'm I know I have one somewhere, but I don't. I could not tell you where it is right this moment or to come up with it fast enough. Here, you know what I have?
Okay,
I have a pen and paper.
Oh, here, I got what I was looking for. Okay, so I want to I'm going to take an example here from another, and I'll get to show off another Robusta thing while we're at it. So
cool.
If you think of a normal alert that you get for an kill, then, I mean, I'm sure you've dealt with debugging kills before, right? So you get an alert, something is killing, good luck. And it doesn't usually have enough context to really know what you need and go and do. So something just added on recently to Robusta that also demonstrates this type of behavior you see with kills is when there's an then we fetch the data from Prometheus about this pod that's been killing. And then we just show you here, like the memory usage for that pod over time. And then you can see right away, okay, here's the memory usage. We crossed this once and went up. We actually went way above the limit. And then we got killed or we went down. And we've stayed below it since then. So that has a different sort of profile than something that's constantly growing or that goes right back up afterwards as soon as it gets killed. So by just looking at the graph, you can sort of understand, okay, what's the behavior here and then what's the fix? Do I just need to raise the limit because it was a one-time spike? Or is there's something here that's leaking all the time? So this is, again, the sort of place where if you're just looking at it from a pure spec versus status perspective, then most of the times when you look at it, the pod is actually going to be running and everything is fine. But sometimes those state changes in that history is actually really important when you want to go and you want to debug something.
Yeah. And it's actually, so this is really interesting because you briefly touched on the characteristics of a memory leak, right? And I think this is really important. So in a lot of CPU and memory are often very, like, if one's increasing, the other one might also be increasing as well. But they're completely independent. And a great example of this is if you're doing video processing, you're going to use a lot of CPU and not a lot of memory. There are other things where you're going to be using them a little bit more jointly. So if you're getting an kill on a memory right, your rest of your pod health metrics might be like totally fine, except for towards the very end. As the memory starts to run out, the CPU will work harder and harder and harder to try to reclaim any available memory to prevent an right? So, and this is true on bare metal, and this is also true in the cloud. So when you're looking at your memory trends on an kill, it is also kind of important to look at the CPU trends, because you can get a better concept of how fast this was truly happening based on how hard the CPU is working at the reclaiming the memory component. And it'll just show up in a little bit more of an upward trend on the CPU usage versus whereas the memory might be a little bit more spiky.
Or I'm going to say now. I'm going to say now, Hilliary, right?
Well, we're not, regardless of CPU limits, right? We're not even talking about CPU limits here.
No, I know. I'm going to say that you have to go to the GitHub repo for Robusta, and you have to open a PR that then adds the CPU graph to this other, because that's the data we need to see.
Oh, that's valid. Okay, I'll do that. I'm actually going on vacation right after this, though, so you actually will have to publicly shame me and remind me.
Okay. I'll remind you.
Shame me and remind me. I would be very delighted to have that be an open source contribution under my belt.
Yeah, sure. So should I talk a little bit also maybe about the other stuff we do with Robusta and the Robusta UI?
Yes, absolutely. We've got about we started late, so roughly about 10 minutes left. So I'm gonna be quiet and let you go ahead and wow us with that single pane of glass.
Okay, so the secret that I'll say first of all is that underneath everything I'm going to show, it's really just the open source. So we're just taking all the observability data that's gathered by the open source, and then we're making it accessible in one place and from all your clusters. Because sometimes when you try and consume alerts in a Slack channel, then you end up with something like this, like 430 plus new messages. This is actually a channel that someone else is running. So in this case, it's going back weeks. But and it's hard to then go through and slice and dice that and to look at that, and you kind of want to see stuff in a different way than what you can just see in a tool like Slack or a messaging app. So that's where the Robusta UI comes in. And like I said earlier, the disclaimer here is the Robusta UI is not part of the open source. It does have a super extensive free tier, so up to 50 nodes free. And for people who need, they can also self-host it. But this isn't part of the open source, just as a disclaimer. Okay, so if I jump over here, then I can see here. Let's get just the video is a little bit. Okay, so I can see here everything that's running in my cluster. And if I have something that's running on multiple clusters, then I can see it here. I can see the different things here that had issues. So for example, here's a pod that was crashing that has some health issues. And I can see the same data. So if before I got that, that notification in Slack and there were the logs there for this crashing pod, I can see the exact same thing here. And here we're just showing all the different evidence that we gathered with all of those different playbooks, and we're showing them to you. Now, the cool thing is I can also see everything on the timeline. So let's say I just go over here and I zoom in. And I'll tell a good story here, even though it's really not true because this is a demo environment that has other weird stuff going on. But I'll tell the story that's usually true. So I come here and I see, okay, and I have some Kubernetes morning events from around that same time. We're also pulling in all the events of what you would get with kubectl get events, the usual data that you would gather here. And I see here this icon that's different from all the other icons. And this icon is a change that happened in my cluster. So we're auditing and tracking all the different changes here that happen in your Kubernetes cluster. And again, we're the official maintainers now of KubeWatch, so it makes a lot of sense. And sorry, I just clicked on the wrong thing to reset that view. So if I zoom in now and I just click on this change, then I can see here the exact change that happened right before that pod started crashing. So it's kind of like Git blame, but for your Kubernetes cluster. And again, this is a demo environment, so the changes didn't actually cause it to crash, and there's all sorts of other weird stuff happening. But usually you would see here, like the new version that was rolled out, and you know what change caused this to happen. And then you'd be able to go and like roll back that change or roll out a fix. So that's one part of what we do in this in the SaaS platform. And we pull in all that data, we put on a timeline. You can see a timeline for each specific microservice. You can see a timeline for all the stuff in your cluster. I can slice and dice that different ways. So I can like look at this per service. I can look at this per the type of error that's happening. And to put this kind of in more technical terms, we're kind of just bringing a front end for Alert Manager that shows you all the alerts in your cluster, but it also shows you the Kubernetes objects alongside that. Instead of just dealing with labels, we have an intimate understanding, okay, this alert is attached to this Kubernetes object. So like another way to think of this is it's an Alert Manager front end that is inherently Kubernetes aware and like has these extra troubleshooting tools. And we also do grouping here. So like if there's an alert here that fired or an event that happened 39 times and I see one row, and again, here's the place where you really want something that you can't just do in a messaging app like Slack, where you have all the stuff that's duplicated. I'll pause here for a second. I don't know if you have questions or comments or if there's anything from the chat.
The only thing I was going to ask about was grouping, and then you showed it, and I was like, fantastic. That's like the thing that, I mean, obviously, you know, that's such a quality of life piece. I do want to thank our Hope9 for wishing me a belated happy birthday. My birthday was on Monday. So appreciate the well wishes. That's very nice of you. And I also, you remembered, so that's also very nice of you. And then, yes, I will enjoy my vacation, I promise.
Mazel tov.
Thank you.
Yeah. So getting back here then, like the second thing that you're going to want to do if you have something like this is now you're going to want to drill down and you're going to want to debug this, or you're going to want to look at this and understand why something is happening. So we have all these different actions built into Robusta to troubleshoot, right? Like we can gather the events, we can run a profiler, we can do all these different troubleshooting actions. So what we're now starting to do is we're starting to expose those in the UI as well. So I can now go and I can like look at the list of pods that's running here, and I can drill down and I can do various actions. Now, right now, the only two actions you see here are really basic, like restarting the pod or fetching its logs. But what we're doing here is we're going to be adding on all the different actions in Robusta, which there are a whole lot of. So to really take all those troubleshooting capabilities, and then it doesn't matter, you can run them automatically and gather the data and send it to Slack. You can run them ad hoc when you need. And going back to like a GitOps workflow, codifying the operational knowledge, you want to let people run debugging stuff sometimes in production if they have to, but you don't want to let them run anything. So it's a really good way to say, okay, here are these 3 approved workflows that you can do to debug, and I'll expose these to you via this button, but I'm taking away your kubectl access.
Yeah, that is super important in highly regulated industries. So people ask me all the time, do SREs at Red Hat have cluster admin? And I always tell them, nope. We're running with highly specific, very controlled RBAC. And like exactly, like that is such an important thing. But also that type of thing, right, where you have some sort of approved actions that can also give, if you're working at something like we're infrastructure as a service a little bit more, right? So our CEE people have access to our monitoring, alerting, and metricing and so forth. So that kind of like, you can do these things and get you have this approved action of get logs, right? That's the thing that our CEE folks will often do. And so that the importance of that control in your UI cannot be overstated, because of like the scope of industries that are using Kubernetes these days and are using Kubernetes with SRE support and so forth.
Yeah, for us, that's the selling point a lot of times when we see these larger organizations. So if it's a Fortune 500 company, then they're going to want something that's really different than what a small startup wants. And then when you build out, also we spoke a little bit at the beginning about the economics of open source. But then when you build out your business strategy and you build out even the way you price a product and you build out all of that, then like there's a question: do you focus on some of the small companies or do you focus on larger companies? And at least for us, we're focused on the larger companies, but this, like small companies sometimes need some of this too. Small companies want to work the best way. And even if you try and monetize it, you're not going to get a lot of money out of small startups. So I was recently speaking to the divisive post hog, and he said something that I really, really liked, which is like, try and monetize, don't try and make money from startups. So like if you're building out all this tooling, then the approach that we've taken is, okay, we'll give it to people for free. And you can kind of start with the smaller stuff that's appropriate for you. And I see the commentary also about having the right tools. And that's very true as well.
Yeah.
Like, we'll give you everything and you incrementally add what you need. And like when you're a big company, then you'll be a paying customer when you really have a massive scale there.
That's going to be my next t-shirt design. It's going to say GitOpsian on the front, and it's going to say, if you have the right tool, you don't need the big hammer. That's going to be my next t-shirt design. No, it's not. I'm never going to design a t-shirt. I just talk about it a lot.
Yeah. Well, it's actually fairly easy. You just have to set up a Printful account. Like I have here the new Robusta t-shirt. And you have on one of the older Robusta t-shirts. And this one says, I love open source loves me. And yours is, of course, a pun on CPU limits, and since my Kubernetes has no limits. So we actually print out like a whole lot of these. Sometimes it feels like we're almost the #1 Kubernetes t-shirt shop in the world.
You know that Red Hat started, I mean, there's a joke that Red Hat started as a t-shirt company, right?
Wasn't it a Fedora company?
No. So the original Red Hat was actually the guy just wore a red baseball cap. And I'm going to sound so bad right now because his name just escaped my brain. And it's like, how can I not come up with his name right now? I'm going to be like, I am embarrassed. But I'm also terrible with names. But yeah, so he was like in his college campus, he was in like the IT room or whatever, and he would help people out. And people would be like, oh, go look for the guy in the red hat because he wore a red baseball cap. And so as the company evolved and it became as he decided to create a company, that was where he got the naming from. I think I literally have this story in like my Story of Red Hat book that should exist on my desk that they ship you with your Fedora. But anyway, shame me very publicly for this name escaping me. I'm going to remember it right when we're not live. It's going to be terrible. I'm so bad with names. Stephanie's like trying to suggest which was it Bob Young or Mark Ewing. Now Mark, I don't remember. Now you're just giving me names and I have no idea anymore.
I love the red hat because it's just the most brilliant marketing gimmick ever. Like you walk around the conference and you see red hat everywhere. Everyone knows what red hat is. So yeah. I love it for that reason. I mean, we try and think about like also what we're going to do at conferences. And we want to do usually something that's like a little educational, like the t-shirt, but like also spreads awareness about Robusta. So I don't think we're ever going to be able to find something that's as good as the red hat.
That was a good story, but it's an interesting story behind why Red Hat is a Red Hat. I don't remember why the change to the Fedora, but they also, so at the very beginning of Red Hat, they sold a lot of t-shirts. It was Mark Ewing's hat. Okay, thank you. I appreciate the smarter people than I with better memories, or faster Google skills, whichever it was. Yeah, so we did actually sell a lot of t-shirt things. So when you say that, I laugh. I'm like, oh, someday Robusta is going to be another Red Hat. I can just see it.
We're doing our best. We just have to keep on delivering, keep on working hard. And I mean, we're heavily invested in Kubernetes. So Kubernetes success there also has been very good for us.
Yeah.
Okay, so I want to show one more thing. Yeah, oh, cool. Someone dropped the link there into the history in Wikipedia. Okay, so I know what I'm doing as soon as this call finishes. I'm going to go through that. I binge a lot on Wikipedia, but I've been trying to, though, have a rule that I can't open up a new Wikipedia article until I close one of the previous ones.
Did you ever play that game where you open a Wikipedia article and you go to the first citation, you click that, and then like you just keep going down that rabbit hole to see where you end up?
Yeah, there's some trick for there though. A game where you have to get between two different articles in the shortest path possible.
Oh,
And then the
fun.
trick is to always like aim to get to philosophy or something. There's some like trick there for like a mega joiner page that connects everything. Okay, but I want to show off just one more thing before we stop. And I want to speak a little bit more about something else that happens all the time. You have an issue that occurs in one cluster and it doesn't occur in another cluster. And you say, what is different about this cluster from all the other clusters? What is different about this cluster? So as part of our vision here for giving you like this one-stop troubleshooting platform where you go when you have any issue in production, then part of that is actually we added on the feature recently where we let you compare different clusters. So I'll just show you what that looks like. So I can either compare different namespaces or different clusters, and that really also corresponds to two different ways that people sometimes do multi-tenancy. So I'm going to assume I have two clusters. I'm just going to select here two clusters. And I can see here a comparison that's hide everything that's identical. So I can see here like the exact difference. I can see here, for example, in this cluster, I'm running an older Robusta runner version. And here's the image on the new one. So it makes it really easy to just pinpoint in a second what the exact differences are when you have an alert that's firing.
I love that. Yeah, it does happen. It happens a lot. What are the differences? It actually just happened in a very two seemingly identical clusters. It was like, why is this failing over here and not over here? This week, that actual production issue we had 3 weeks ago. I wasn't the person who actually handled that issue myself, so I don't remember what the like subtle difference ended up being that caused the problem. But yeah, tools to sit there and like literally compare. Okay, we've got this customer. They have these two clusters. Their clusters are basically identical. So where is that super secret difference that's causing the problem? And that's you need that to be able to manage things like cattle instead of pets.
Yeah. Are we out of time?
We are so out of time. I'm so sorry. We will have to have you back because this was extremely enjoyable. I already made my big announcements at the beginning, so we're good. I'm going to remind everybody again to like, subscribe, follow Natan and I on Twitter. Sometimes we argue with each other. It's fantastic. I think, what do you say? When you have two Jews in a room, you have three opinions.
Yeah. Well, you're probably right most of the time. You are more experienced than me, especially when it comes to SRE stuff. So I feel like an imposter sometimes because I didn't have that much of I have a lot of software engineering background, but somehow I like jumped from there to then ended up in a co-founder role, like without doing as many years of SRE as you. So, I mean, I think you're probably right on most of the issues that we end up disagreeing about.
And I think when we disagree, sometimes there's places that reasonable people can disagree. But either way, we have a great deal of fun arguing with each other on the internet. I have an immense amount of respect, and I like respect for you, and I like you a lot. So we'll have to have you back sometime.
Likewise. Thank you very much, and thank you to everyone who joined us.
All right, thank you, folks, and we'll see you in 2 weeks. Christian Hernandez. Wait, is Christian Hernandez joining us? Christian Hernandez is joining us on August 11th, to talk about his book. About GitOps. What was the name title book? I'm the worst. I'll post it on Twitter and be a much better host for you all after my vacation. I'm already vacation brained. That's it.
Okay, so we have a question here from, is it pronounced Louis?
Probably, I don't know. Right under the wire. All right, go. And then we really do have to let these poor folks, Stephanie has other things to do.
Okay, so I don't know if you can see with the screen share, but I'm actually taking a screenshot of the I'm taking a screenshot of this to send to my product guy. The answer is not yet, but you can read between the lines on that. And if it's something you're interested in, then please message me on LinkedIn or on Twitter, or reach out, or we have a Slack community as well. So come and talk to us there, because we have a product guy who would be very, very interested in talking to you before we launch it and getting some early feedback. So please reach out. But yeah, like the obvious evolution of what we do, right? Like, you have the wrong limit, like we're going to tell you what the issues are. So we're telling you there's an issue, or there's throttling, or there's some other issue going on. We should really tell you what the fix is, right?
Yeah. I would love to be involved in that. If you feel like adding me to your conversations, I would be excited.
Yeah, of course.
Yeah.
Will do.
All right, great. Okay, for that, thank you again so much for coming and teaching us about Robusta. Let's have you come back sometime. I do have to tell everybody goodbye, and don't forget, folks, to choose your technical debt wisely. We'll see you in 2 weeks.